Chapter 2 Polynomial Session 4. Let's start. Let's start with the factorization of polynomial. Factor theorem. What is factor theorem? If p of x is a polynomial of degree n is greater than 1 and a is any real number and n is any real number, then x minus a is a factor of p of x, then p of a is equals to 0. That we already see in the previous lecture. If x minus a is a factor of p of x, then p of a is equals to 0, right? That we already see that x minus a is equals to 0, therefore x is equals to a, and therefore p of a is equals to 0. Okay, so that could be understood. Now p of a is equals to 0, p of a is equals to 0. The second point, if p of a is equals to 0, then p of a is equals to 0 if x minus a is a factor of p of x. If p of a is equals to 0, then x minus a is a factor of given polynomial. For example, let me take an example here so that could be understood. So p of x, right, see here, the p of x is equals to x cube minus x minus 6. Okay, now let's check with the, now x is equals to 3, or you can say x minus 3. We have to check whether x minus 3 is a factor of given polynomial or not. So if you compare it with the 0, x minus 3 is equals to 0, so therefore x is equals to 3. So we have to put here p of 3. So instead of, here it is x square, so here we have to put the 3 instead of x. So 3 square minus 3 minus 6, 3 square 9, minus 3 minus 6 minus 9 is equals to 0. See, each and every condition is satisfied over here. The first thing, x minus a is a factor of p of x. X minus a is a factor of p of x. X minus 3 is a factor of p of x. Why? Because p of a is 0. Here p of 3 is 0. Instead of a, we put here 3. So p of 3 is equals to 0. Right? Then x minus a is a factor. We see x minus 3 is a factor of x square minus x minus 6. Right? See here, let's check with the example. Check whether x minus 1 by 2 is a factor of the polynomial 2x minus 1 or not. So what we have to do is, we have to compare x is minus 1 by 2 is equals to with the 0, so is equals to 0. So therefore x is equals to 1 by 2. So compare with the 0, we get x is equals to 1 by 2. Now the second step is what? This p of 1 by 2 is equals to 2 into 1 by 2 minus 1 is equals to 2 and 2 cut, 1 minus 1 is equals to 0. Yes, it is 0. Is it 0? Therefore x minus 2 is the factor of p of x. Okay, so in that manner we can understood this factor theorem. Right, now let's move ahead with the exercise 2.4. Exercise 2.4. Question number 1. Determine which of the following polynomial has x plus 1 a factor. Which of the following polynomial has x plus 1 a factor? If x plus 1 to be a factor of the polynomial, then we have to compare it with the 0. So therefore x is equals to, if 1 goes on to the another side, it become minus. So x is equals to minus 1. So we need to check the value of p of minus 1. So we need to check the value of p of minus 1. If it is equals to 0, then it is a factor. But if it is not equals to 0, then it is not the factor. Simple. Okay. Now see, compare. The first step is what? Compare it with the 0. So compare it with the 0. The answer is x is equals to minus 1. Now p of x is equals to, so what we do here is we need to find out p of minus 1. We need to find out p of minus 1. So wherever you find out the x, wherever you find out x in this equation, you need to put the minus 1. So minus 1 cube. See here x cube, here x cube. So minus 1 cube. X square minus 1 square. X minus 1 and 1 as it is. Okay. Now minus 1 cube minus 1. Minus 1 square plus 1. Minus 1 as it is and plus 1. This is the simplification that you know very well. Right. Plus 1 minus 1 is 0. Plus 1 minus 1 0. So answer is 0. If it is 0, see p of minus 1, here p of minus 1 is equals to 0. So therefore x plus 1 is a factor of the given polynomial. So therefore x plus 1 is the factor of given polynomial. Now see another sum, x to the power 4, x to the cube, x square plus x plus 1. Now first step is same compared with the 0, x is equals to minus 1. So we need to check p of minus 1. So wherever you find out the x, you need to put the minus 1. So minus 1 power 4, minus 1 cube, minus 1 square, minus 1 and plus 1. Wherever you find out the even power, minus becomes plus. So it is plus 1. If it is an odd power, it becomes minus. So minus 1. So plus 1, minus 1, plus 1, minus 1, plus 1. Right? Plus 1, minus 1, 0. Plus 1, minus 1, 0. What is remain? 1. Right? Plus 1, minus 1, 0. Plus 1, minus 1, 0. What is the remaining thing is 1. So p of minus 1 is equals to 1, and which is not equals to 0. Which is not equals to 0. Therefore, x plus 1 is not the factor of given polynomial, because if p of minus 1 is not equals to 0, then x plus 1 is not the factor of given polynomial. Right? Now move ahead with the another sum, and that is x to the power 4, 3x cube, 3x square, x plus 1. First step is x plus 1 is equals to 0, x is equals to minus 1. Then x to the power 4, so minus 1 square, minus 1 cube, 3 into minus 1 cube, 3 into minus 1 square, minus 1 and plus 1. If it is even power, positive. If it is odd power, negative. So plus 1. Now here it is minus 1 into 3. So minus 3. Positive power is going to be the plus 1. So 3 ones are 3 plus 3. And here minus 1 and plus 1. So here plus 3 minus 3, 0. Plus 1 minus 1, 0. What is remain? 1 is remain. So 1 is not equals to 0. And if it is not equals to 0, what we can say? We can say that x plus 1 is not the factor. X plus 1 is not the factor of the given polynomial. Now another sum, and that is x cube minus x square minus, see, this is very important. This is the single term. This is the single term plus square root of 2. The same thing we need to repeat here. The first step is we need to compare x plus 1 with the 0. X is equals to minus 1. P of x is equals to x cube minus x square minus 2 plus root 2. Now wherever you find out x, we need to put the minus 1. Minus 1 cube minus 1 square, here minus 1 and plus square root of 2. Now if it is odd power, answer is negative. If it is even power, answer is positive. So minus 1. Now here minus 1 square becomes plus 1 and minus 1 is there. So minus 1 plus 2. So minus 1 into minus 1 minus 1. Minus 1 minus 1 plus 2. Okay. So minus 1 minus 1 minus 2 plus 2, it becomes 0. So this is become 0. Now here it is minus 1. So see, this is the very single term that I had already explained, that minus into 2 plus square root of 2 into minus 1. So minus 1 into minus, it becomes plus. So answer is simple, plus 2 root 2. So that thing is written over here, and that is 2 root 2 plus square root of 2. Right? So here this 2 and 2 is cut. So what is remaining is, what is the remaining? So root 2 2 times. So the here is answer, it is not 1, my mistake. Here it is not 1, here it is 2 root 2. Here it is 2 root 2. and 2 root 2 is not equals to 0. 2 root 2 is not equals to 0. If it is not equals to 0, if it is not equals to 0, see here, once again I am repeat, here you have to write down the 2 root 2, right? 2 root 2 is not equals to 0, therefore x plus 1 is not the factor of given polynomial. Okay, now let's move ahead with the question number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Simple. We need to compare g of x is what? X plus 1 with the 0. So therefore x is equals to minus 1. Now we need to find out the value of p of minus 1. If it is equals to 0, then yes, it is a factor. If it is not equals to 0, then no, it is not a factor. Simple. So x is equals to minus 1. Now wherever you find out x, we need to find out the value of p of minus 1. So wherever you find out, wherever you see the x, you need to replace it with the minus 1. So 2 into minus 1 cube, minus 1 square, 2 into minus 1 and minus 1. Minus 1 cube is minus 2. Minus 1 square is plus 1. So here plus 1. See here minus 1, minus 2, minus 1 into minus 2 plus 2. And here minus 1. Now plus 2 minus 2 0. Plus 1 minus 1 0. So answer is 0. If it is 0, then yes, we can say that g of x is the factor of p of x. G of x is a factor of p of x. So x plus 1 is a factor of p of x. Simple. Okay. Now question number 2. G of x is x plus 2. So x plus 2 is equals to 0. If 2 goes on to the another side, it becomes minus. So x is equals to minus 2. So now we need to find out the value of p of minus 2. If it is equals to 0, then it is a factor, and if it is not equals to 0, then it is not a factor. So p of minus 2 here. So wherever you find out x, you need to put the minus 2. Minus 2 cube, minus 2 square, and minus 2. Minus 2 cube, minus 8. 2 square 4, 4 3s are 12. Here 3 2s are minus 6 and plus 1. C. So minus 8, minus 6, minus 14. 12 plus 1, 13. Answer is minus 1. So minus 1 is not equals to 0. Minus 1 is not equals to 0. So if it is not equals to 0, then what? Then we can say x plus 2, that means g of x is not the factor of p of x. G of x is not the factor of p of x. That means x plus 2 is not the factor of p of x. Okay. You can write down in both the ways, whether x plus 2 is not the factor of p of x, or you can directly write down that g of x is not the factor of p of x. Now the question number 3rd. P of x is equals to x cube minus 4x square and x is minus 3. So x minus 3 is equals to 0. So therefore x is equals to 3. Now we need to check the value, find the value of p of 3. We need to find out the value of p of 3. If it is equals to 0, then it is a factor. If it is not equals to 0, then it is not a factor. Simple. So here it is the x is equals to 3. Now we have to find out the value of p of 3. So here wherever you find out the x, you need to replace it with the 3. So 3 cube, 3 square, 3 and 6. 3 cube is 27. 3 square is 9. 9 4 is 36. 3 as it is and 6 as it is. Now 6 plus 3 9. And 27 plus 9 is equals to 36. So plus 36 minus 36 is equals to 0. So p of minus 1 is equals to 0. If it is equals to 0, then what we can say that x minus 3 is the factor. X minus 3 is the factor of the given polynomial. Question number 3. Find out the value of k. Question 3 is find out the value of k. If x minus 1 is a factor of, it is directly given. See here, it is directly given that x minus 1 is a factor of p of x. X minus 1 is the factor of p of P of x. If it is a factor, then what we can say? We can say x minus 1 is equals to 0. So x is equals to minus 1. It is directly given the factor. Therefore, P of 1 is equals to 0. Right? Because it is a factor. If it is a factor, then P of 1 is equals to 0. Right? So x is equals to 1. So P of 1 is equals to 0. See here, wherever you find out x, you need to put the 1. So 1 square plus 1 plus k, we need to compare it with the 0 because P of 1 is equals to 0. 1 plus 1, 2 plus k is equals to 0. If 2 goes on to the another side, it becomes minus. So therefore k is equals to minus 2. K is equals to minus 2. So the value of k is equals to 2, right? So the question is x minus 1 is a factor of P of x, and find out the values of k in each case. Find out the value of k in each case. Question number 2, right? So here in the same case, x minus 1 is equals to 0, x is equals to 1, P of 1 is equals to 0. Here 2 into 1 plus k into 1 plus square root of 2 is equals to 0. 2 plus k plus square root of 2 is equals to 0, and therefore k is equals to 2 goes on to the another side and root 2 goes on to the another side, it becomes minus. So minus 2 minus root 2, minus 2 minus root 2. Here what I did is take out minus common. If minus is common, each and every sign gets changed. So k is equals to minus in bracket 2 plus 2. Okay, so that is the value of k. Now let's see another sum. Here the same thing, compare x minus 1 with the 0. X is equals to 1, so therefore P of 1 is equals to 0. So k into 1 square minus square root of 2 into 1 plus 1 is equals to 0. So k minus root 2 plus 1 is equals to 0, and therefore k, if minus root 2 goes on to the another side, it becomes plus square root of 2. If minus 1 goes on to the another side, it becomes minus 1. So k is equals to square root of 2 minus 1. So therefore k is equals to square root of 2 minus 1. Hence the value of k is square root of 2 minus 1. Right? Fourth sum, same. P of 1 is equals to 0, and therefore k into 1 square minus 3 into 1 plus k is equals to 0. Therefore k minus 3 plus k is equals to 0. 2k is equals to 3 goes on to the another side, it becomes plus, and here k plus k, 2k. So that implies now 2 from the numerator goes into the denominator, therefore k is equals to 3 by 2. So therefore k is equals to 3 by 2, and the value of k is 3 by 2. Right? Simple sum. Now question number 4, factorization. Very much important topic as far as your SSC is concerned. Right? So learn it very wisely. Just follow this each and every step. Right? See here, it is, if you compare it with the ax square plus bx plus c. So what is the value of a? 12. What is the value of c? And that is 1. So what I have to do is I have to multiply a and c. So a into c is what? 12 into 1 is equals to 12. Simple. Now I want minus 7 as a middle term. And I have a 12. So what I do is I need to find out the factors. So first factor is 12 ones are. Another is 6 twos are. Another is 4 threes are. Right? That's it. You cannot find out another factors other than this. Now what I have to do, I simply have to add this, and I want to find out the minus 7. Simple, right? So what I'm going to do is 12 plus 1 is equals to 13. Is it possible? No. 6 plus 2 is equals to 8. Is it possible? No. 4 plus 3 is equals to 7. Is it possible? Yes. So we are going to take the 4 and 3, because 4 threes are 12. See, listen. 4 threes are 12. Multiplication is 12 and addition is 7. Multiplication is 12 and addition is 7. So we are going to take 4 and 3. So minus 4x minus 3x minus 4x. Now why? How can you know that whether we have to take the minus or the plus? Right. So at that time we need to check the middle term signature. Middle term is negative. So both are negative in case of addition. In case of addition. So here minus 4 and minus 3. Now from this 2, what is taken out common? So see, it is 12x square minus 4x, right? So this is how I can write this. So it is nothing but the 4x into 3x minus 4x. So out of this two term, what is common? 4x is a common. So 4x is a common, in bracket 3x is remain minus 1. 4x in bracket 3x minus 1. Same here, minus 3x plus 1. If nothing is taken out common, we have to take minus plus 1 common. But the third term, see, this is the third term. If it is a plus 1, we have to take plus 1 common. If it is a minus 1, we have to take the minus 1 common. If minus 1 takes out common, if minus 1 is common, each and every sign gets changed. So here it is going to be the plus 3x and here it is going to be the minus 1. So this is 3x minus 1. Now out of this two term, now this is the one term and this is the second term. Out of this two term, 3x minus 1 taken out common. So here 3x minus 1 is taken out common. So what is remaining is 4x and minus 1. So 4x minus 1 in bracket 3x minus 1 is the answer. Okay. If we don't get this, see the another sum. Here a is 2 and c is 3. So 3 2s are 6. Now I have to find out the factors of 6. 1s are 3, 2s are, that's it. Okay, now what I have to do is, now I have to do the addition. Why? Because why we have to do the addition? Because 6 is plus. If 6 becomes negative, then we have to do the subtraction. Simple. Now 6 plus 1 is equals to 7. So what we want? We want 7. So we have to take this one. Now let's check. 3 plus 2 is equals to 5. So this is not possible. So we have to take 6x plus x. Simple, right? Now out of this 2, what is common? 2x. Out of this 2, nothing is common, then we have to take out the 1 common, but we have to take the sign of third term. Okay? So out of this two term, what is common? Out of this two term is x plus 3 is common. X plus 3 is common. So here I have to write down the x plus 3. And what is remaining is 2x plus 1. So here 2x plus 1. So what is the answer? The answer is 2x plus 1 into x plus 3. What is the answer? So answer is 2x plus 1 and x plus 3 is the answer. So this is the answer. Okay. Now let's move ahead with the another sum, and that is 6x square plus 5x minus 6. Now 6 are 36. See here. Here it is plus 6 into minus 6. Plus 6 into minus 6 is what? So minus 36. So minus 36 and I want a 5 here. Right. So minus 36. Now what I have to do is find out the factors. 36 ones are 36. But find out a lots of factor is if I know directly that 9 4s are 36. 9 4s are 36. Now the middle term sign goes with the bigger one, and the another one goes with the smaller one. So now 9 4s are minus 36. 9 4s are minus 36. Now plus 9 minus 4 is equals to plus 5. So plus 9x minus 4x is equals to plus 5x. So instead of 5, what I have to put? I have to put the 9x minus 4x, right? 9x minus 4x. So I'm going to do it in a step by step here. So 6x square plus 9x minus 4x minus 6. Now see, out of this two term, what is common? Simple, it is 3x common. If 3x is common, so here 3 2s are 6. Here 3 3s are 9. Third term's sign is common, so minus is common. Out of this 2 is common. If 2 is common, then what is remaining is 2x plus 3. Now out of this two term, what is common? The common thing is 2x plus 3. So 2x plus 3 is common. What is remaining? 3x. What is remaining? Minus 2. So answer is 2x plus 3. 3x minus 2 is the answer. Right? 3x minus 2, 2x plus 3 is the answer. Yeah, the only sequence is changed, and that is fine. If you do the 5 2s are, answer is 10. And if you do the 2 5s are, answer is 10. Right? In the multiplication or addition, sequence doesn't matter. In the addition and multiplication only, sequence doesn't matter, right? Now in this sum, what I have to do is, see, 3x square minus x minus 4. A is 3 and c is minus 4 is equals to minus 12. Right, so here it is simple. 3 minus 4 is equals to minus 1. 3 minus 4 is equals to minus 1. If you put here x with, so answer is minus x. Answer is minus x. So minus 4x plus 3x. Now see here, out of this two term, what is common? Only x. If x is common, 3x minus 4. Here nothing is common out, so plus 1. So plus 1 is common out, and what is remaining into the bracket, and that is 3x minus 4. Now out of this two term, what is common? 3x minus 4 and 3x minus 4. So 3x minus 4 over here, and here x plus 1. So answer is this. Now that's it for today. Work hard, practice this kind of a sum. Practice this kind of a sum very cautiously. Okay, so let's meet into the next lecture. Till then, bye bye, see you, stay home, stay safe.